Good afternoon, everybody. Welcome to a sunny afternoon of organic chemistry with your host, me, Dr. White. I've got some sad news for you. It's our last lecture together, our last time together. Next Monday, we'll have the final. I'll send out the email with the password for the final at roughly 1 p.m. So you don't have to show up. I'll be here for a half hour because the contract requirements for faculty, but you have until next morning to get your final done and uploaded. And I will get them graded by latest Sunday, hopefully a lot earlier, but I'll get that out. What I will do is in D2L, I'll put all your points, and I apologize for yesterday. Sometime by tomorrow, I'll have last week's lab and the lab you're handing in today done, and also any past labs, and also any regrading I promise. Yesterday I got, how should I say, blindsided with a lot of extra work that had nothing to do with teaching that I didn't expect, and therefore it got me behind. I'm behind. As soon as this class is over, I'll upload Monday's. I've already made it, but I have to upload Monday's lecture to YouTube. And today's lecture I'll probably get hopefully sometime tomorrow, but it's been busy time yesterday. Busy. All right. Like I said, next week, you don't have to come to class Monday and Wednesday. You really don't, but I'll show up for a half hour or so. If you want to stop by, say hello, you can. If you don't. But yeah, stop by, say hello to Dr. White, make me happy. But, anyways, also next Monday and Wednesday night, I will have my office hours because I'm required. So if you want to stop by and say hello and shoot the breeze with Dr. White, go right ahead. I'll talk about anything except how to do anything illegal, which I won't talk about. All right. And as I do if we were face to face, I will not be sending out individual points for each question on the final. I don't hand back the final after I grade it when we are face to face, so I won't do that. And with that, before I get further, I've got something to show you. It's show and tell from Dr. White. A friend of mine, his wife teaches at middle school in Fort Wayne. Everybody see the cartoon? Let me make it a little larger. Everybody see it now? I thought it was funny, and so did the faculty at both schools. Uh, but no, I don't smoke. And it's not about me. But anyways, it has been, especially this class with some of you people showing up at the last second. Where are my students? No, I'm not looking at the microwave. All right, let's get to work. Let me just close this. All right, everybody see chemical reactions on their screen? Thank you, thumbs up, people. All right, I ended up, we had talked about how if you take a aldehyde or ketone, react it with 1 mole of an alcohol and acid, you get a hemiacetal. Keep your eye on the carbonyl carbon. Remember, carbonyl, carbon, double bond to oxygen. When you have 2 molecules or moles of alcohol reacting with aldehyde or ketone acid, you get an acetal. Special case, glycerin, ethylene glycol, not glycerin, ethylene glycol. There are 2 alcohols in the same molecule, same thing happens, but ours connected, and students forget to put that bond between CH2 and CH2. Don't, please. Now, once you get a hemiacetal react with acid and water, what do you get? You get the aldehyde and the alcohol you would have used to make that hemiacetal. And once you react the acetal or ketal, You also get the aldehyde or ketone plus the alcohol. Remember, we don't balance chemical equations unless we have to. In my class, you don't, but I still put the two there because they're the twins. And the key thing here is these are the only two examples in all of organic chemistry where you have a single bonded oxygen to a carbon atom, the same carbon atom. And when you treat it with acid and water, they give the same products, the aldehyde, ketone, and the alcohol you would have used to make them. Now, fun part, Grignard. Remember my hero in organic chemistry, one of them is Victor Grignard, the great French chemist. And Dr. Grignard discovered or created, I like created better, invented, take an alkyl halide, react it with magnesium, you make the Grignard reagent. Remember, magnesium is to the carbon, excuse me, that has the halogen on it, and the halogen is bonded to the magnesium, not the other way around. And X here can be chlorine, bromine, or iodide. Now, once you get a Grignard reagent, you can react it with a ketone or aldehyde. And they attack the Grignard bonds to the carbonyl carbon. That's where all the fun is. And you do something very special, very rare in organic chemistry. You make a carbon-carbon single bond. This opens up to an alcohol. Now, the carbonyl carbon is a double bond to oxygen. So if you add hydrogen and catalyst, you break the pi bond, and each atom of the double bond, carbon oxygen, gets a hydrogen. Now, since this could react with double bonds if you had it in our prime or our double prime, which is real life, we came up, and that was H.C. Brown, came up with lithium aluminum hydride and water, second step acid and water, essentially does the same reaction, but this reagent will not react with carbon-carbon double bonds. It will react with carbon oxygen to form an alcohol also. As I note here, you should know how to do synthesis here and here, but for a Grignard, I will never ask you to do a synthesis. Now, the alpha carbon, the carbon bonded to a carbonyl of an aldehyde or ketone, but for this class, I'm just making it easier for the ketone, aldehyde, is acidic. And with base, sodium hydroxide, in presence of a solvent like water, you can pull that off, form what's called the enolate anion, and that will attack a carbonyl of another aldehyde. And you do another very special rare thing. You form a carbon-carbon single bond, and this is called the allyl condensation.
Can you just go through that one more time, please?
Allyl condensation?
Yes.
Okay. This happens, and I'm done. No, I'm sorry. Let's do it in the whiteboard. I'm going to have some fun. Dr. White loves enolate anions because that's what I did my PhD thesis on. Very specialized enolate anions. PhD creating enolate anions, me. Now, the alpha carbon is acidic. That means you can pull a hydrogen proton off with a base. And I have never done solid state chemistry. You're always in a solvent, just like in your body. And this forms the enolate anion, which attacks that. You take off one hydrogen from the alpha carbon, everything else attached to it is still there. Then it bonds to the other carbonyl, which opens up to an alcohol. And what's attached to the second one, this is still attached. And you've done something very special, very rare. There's only about 20 cases of all the hundreds of organic reactions that you can make a carbon-carbon single bond. And this is one of them. And that's how you do it. Does that help, Tom?
Thank you.
You're welcome. And with that, I'll ask, is there any questions on the material from test number 2? Going once, twice, done. Let's go to material test number 3. Everybody see test number 3 review? Thank you. You guys got the fastest thumbs this side and another side of Mississippi. Thank you for helping me out. All right. Test number 3. We started with carboxylic acids, carbonyl with the hydrox group and R group. How do you name them? You find the longest chain with the carbonyl carbon, name it as an alkane, drop the E at OIC in the word acid. The carbonyl carbon is number 1. Everybody knows that, so we don't have to put that down. Now, there are 2 common names you should know. One is when R is a methyl group, acetic acid. And if you put acetic acid in water, a small amount of acetic acid, 4% roughly, we call that vinegar. And the other one is when R is an H, that's formic acid from the fire ants. And the third one, which is both the common name and the IUPAC name, when R is a benzene ring, that's benzoic acid. Just like when R is a benzene ring and OH is a hydrogen, that's benzaldehyde. Now, and alkyl groups you number from the carbonyl carbon 1 on, as you've done with chain. Now, carboxylic acids are acids because they're a proton donor. So if I react it with a base, and for this class, I'll just stick to these hydroxide bases where M is lithium, sodium, or potassium, you form the carboxylate anion. And later on, I taught you how to name them, but not now. Now, a special base that was the first chemical reaction I ever did with my hands when I was born, or maybe before. Your body's doing chemical reactions, but my father taught me he'd take a carboxylic acid when R is methyl, vinegar with sodium bicarbonate, you'll get the carboxylate anion, water, and CO2 given off as a gas. Everybody remember the little rocket ship story? I can still picture it in my mind. God, it was so long ago, too long ago. The other thing is with sodium bicarbonate, tomatoes, like in tomato sauce and tomato paste, when you make spaghetti, have citric acid, a carboxylic acid. And my father taught me one of the things was put some in there, not a lot, and that will neutralize some of the acid and make it much milder and much nicer tasting, smoother. Ooh, have you ever had shots of smooth spaghetti sauce? Anyways, no, I'm getting silly now. But that's the good thing. Don't forget the other thing he taught me. Put just a pinch of cinnamon in there. Tastes just like the professional spaghetti sauce. All right, how do you make a carboxylic acid? You take a primary alcohol and oxidize it. Remember, this means oxidizing. Now, there's a dilemma you might have, and you'll say, well, Dr. White, you said if you take a primary alcohol, you can oxidize it to aldehyde. And the answer is yes. Now, what I haven't taught you this semester, which you don't teach 2-semester undergrad course, but at my level, depending on the reaction conditions, you can stop it at the aldehyde or go all the way to carboxylic acid. Therefore, if I do put that on a test, I shouldn't say a test now, on the final, I will accept either answer as correct for primary alcohol being oxidized. But you can take a aldehyde and oxidize it to carboxylic acid, replace the H with the OH. And one last, a really neat way is if you take a Grignard reactor with CO2, you make a carboxylic acid, second step acid water, that's 1 carbon longer than the R group you started with. This R group, like a Grignard attached to carbonyl, attacks the carbon of CO2. And let me, I got time. And if you notice, carbon dioxide has 2 carbonyls, both to the same carbon. And you know a Grignard, let me get this out of the way. A Grignard attacks the carbonyl and it opens up the carboxylate anion, which when you add acid water, gives me a carboxylic acid of 1 carbon longer. And these are real cool reactions to run, because in the lab, usually we do it dry ice. And the Grignard, dry ice is cold, if you don't know by now. Now, let's talk about a new functional group time, and that was the ester. And the ester is where you replace the OR of a carboxylic acid with OH of a carboxylic acid with OR prime of an ester. And this is an ester. And R prime, as you learn, is like X and Y. In math, R and R prime are just groups of carbon and hydrogen. I used the ones moiety. My PhD advisor loved to use that word. And how do you name an ester? You name R prime as the alkyl group it is in the front. And then there are 2 ways of doing it. The IUPAC way is assume R prime is H, name that as a carboxylic acid, drop IC in the word acid, and add ATE. I had a very sharp 170 student a while ago said, oh, I got a better way. That's find the longest chain in the R and the carbonyl carbon of the ester, name it as an alkane, drop the E, add OATE. Either way, you have R prime in front. This works except when R is a benzene ring, then you got to use 2A. Otherwise, you can use 2B or not 2B. That's the question. I can't stop doing that. Now, there are one common name of an ester, and that is ethyl acetate. Now, while we have that, when you do a carboxylate anion, or also known as carboxylate salt, I never use that, I call it an anion, you name it the same, similar to an ester. What M plus, the cation, you name as the element it comes from, Na plus sodium, La plus lithium, etc. in front. And then the rest of this, you name just like ester 2A or 2B, or not to be, that's the question. I can't resist doing that. And as I promised for test number 3, I'll promise now, I will never give a nomenclature question where there's alkyl groups on the R group of an ester carboxylate anion. Not that I don't know how to do it, but it's pretty tricky and I'm gonna be nice. Don't tell anybody I'm being nice, okay? Speaking about being nice, if you liked what I did this semester, go to ratemyprofessor.com and write something down. Well, if you didn't like what I did for this semester, you can go to ratemyprofessor.com and write something down. If you really, really, really like what I did this semester, go to the Board of Trustees. You can find that on the website and send them an email. And if you really, really didn't like what I did this semester, you can do the same thing. Finally, as they've sent out emails to all faculty, including me, if you haven't done your student evaluations, please do it. I'd appreciate it. End of the commercial. Now, esters are responsible, and you should know, for the smell of flowers, which hopefully one of these days will start blooming everywhere, and the smell and taste of fruits and vegetables. And I don't have down here, but the next time you smell a perfume, your own or somebody else's, you're smelling esters. See, organic chemistry is everywhere. Now, how do you make an ester? The the Fischer esterification, carboxylic acid, alcohol, acid catalyst, you make an ester. And the carbon here with the hydroxyl group is in R prime is the carbon with the oxygen in R prime here. Now, reaction of esters, as you learned, this one is really important. You take an ester, react it with acid and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. Now, if you take a ester and react it with a base, and I'm sticking to the alkali metal hydroxides, where M is lithium, sodium, or potassium, you get back not the carboxylic acid you would have used to make that ester, but the carboxylate anion of that carboxylic acid, because in base, this will immediately form this carboxylate anion, but you will also get back the alcohol you would have used to make that ester. Next, new chapter, new stuff. And this is one of my favorite areas because it helped make me make a lot of money over the years. And that's amine and amine derivatives. Remember, derivative, something that's made from whatever you call, like amines, derivatives are made from amines. I'll never ask you, but there's primary, secondary, and tertiary. And remember, there are 4 bonds to carbon, but nitrogen can have 3 or 4, depending on what it is. If it's an amine or an amide, I'll teach you. So, oops, let's fix that. It's 3 bonds. And quaternary ammonium salts and amine salts are 4 bonds. And that's a little tricky, and students sort of get tricked up on that, but don't you, please. And I just asked you to learn the common names for amines, and that's name the alkyl groups that are attached to nitrogen, put that in the front, at the end, add the word amine. Now there's a special amine that I asked you to learn. When R is a benzene ring, it's a primary amine. I didn't ask you to learn primary, secondary, tertiary, even though I do use it and I taught you it. That's aniline. Now, quaternary ammonium salts, you name each R group as the alkyl group that's attached to it in front. Then you add the words ammonium halide. And ammonium halide, the halide, if it's chlorine, it's chloride. If it's bromine, it's bromide. If it's I minus, iodide. And don't forget, everything you're looking at on the screen right now is in the lecture folder of D2L. Now, for amine salts, when there are 3 R groups, or it could be 1 or 2, note R prime and R double prime can be hydrogen, they can be alcohol, but at least 1 hydrogen on that nitrogen, and it's got a counter ion because it's a charge, all molecules have a net 0 charge. You name it the same as quaternary ammonium salts. How can you tell the difference? Amine salts never have 4 alkyl groups. Quaternary ammonium salts always have 4 alkyl groups. And I've been good, Dr. White, because I didn't use slang. If you work in quaternary ammonium salts, and I've got 9 patents in that, or a number of patents in that area, we call them quats for slang. Nobody says quaternary ammonium salt, but I've been good and haven't taught you any slang, well, I just did. But don't forget, things that are near and dear to my heart, you should know, and quaternary ammonium salts are used as fabric softeners and disinfectants, or antimicrobial compounds. And that's very important, two uses of them. And they're also used in places like air conditioners. But you didn't know that. Look at your air conditioners and things like that. Now, how do you make an amine? If you take an alkyl halide, react it with ammonia, you make a primary amine in the presence of base. X can be chlorine, bromine, or iodine. Take a primary amine and react it with an alkyl halide, you'll put another R group on there, and you get a secondary amine. And if you take a secondary amine, react it with an alkyl halide and base, you'll make the tertiary amine. And finally, something very shallow and important to Dr. White, because this reaction really paid my bills and my mortgage and a whole lot of other things. You take a tertiary amine, 3 R groups on a nitrogen, react it with an alkyl halide, presence of base, to make a quaternary ammonium salt. Now, an excellent way of making a primary amine is if you take a nitrile, carbon triple bond to nitrogen, they're 2 pi bonds, and you know pi bond, what can you do with it? You can hydrogenate it. Remember, bracket excess closed bracket means you've got all the hydrogen in the world that will react with anything hydrogen will react with. And in this case, the 2 pi bonds, remember the catalyst can be nickel, platinum, or palladium. And this was actually the first reaction I did research on in industry when I joined, then it was called RMAC, then became AXO, or RMAC, AXO Chemie, and then now it's Axel Nobel, and they sold that off, now it's Noria. Anyways, you break the 2 pi bonds in each atom of the carbon nitrogen triple bond. Hold on. No, about to get my, anyways, you get 2 atoms of the, hold on. All right, last ring. It worked. It listened to me. And each atom of the carbon nitrogen triple bond gets 2 hydrogens. And notice you can write it like this is a primary amine. Now, amines are bases. If I react it with an acid like HX or hydrochloric, hydrobromic, or hydroiodic acid, you have a proton transfer and you make an amine salt. Remember, R prime and R double prime in this case can be hydrogen. This will work for a primary amine, secondary amine, or tertiary amine. Now, new functional group is the derivative of an amine and a carboxylic acid. It's called an amide. And here you have a carbonyl with an R group, nitrogen, R prime and R double prime. R prime and R double prime, one or both, or none can be hydrogen. How do you make a amide? You react a carboxylic acid with either ammonia, amine, primary amine, or secondary amine. In this formula or equation, R prime and R double prime, one or both, can be hydrogen, and you form an amide. I didn't ask you to learn any nomenclature for amides, even though they're both IUPAC in common. Now, once you have an amide, if you react it with acid and water, I'm going to use the HCl because that's the acid in your stomach, and you learn later on that's how you break down proteins. And here you have an amide, HCl and water. There's a carboxylic acid you would have used to make that amide, but an amine is a base. In the presence of acid, you form the amine salt. Now, you can also react that with base and water, and here you get not the carboxylic acid, but a carboxylic acid is acidic, sodium hydroxide is a base, so you get the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine of you would have used to make that amide. And then I talked about heterocycle compounds, And for heterocycle compounds, that all that area about illegal drugs we talked about, heroin. I didn't talk about mescaline. But anyways, heroin or cocaine, all that, they're all heterocyclic compounds. But the only thing I asked you to learn was one. You should know what is a heterocyclic compound. That's a ring with carbon atoms and other atoms such as oxygen or nitrogen. And I asked you to learn one heterocyclic compound that was pyridine, which is this. Notice it looks like benzene, except one of the carbons is replaced by nitrogen. And as I showed you during the semester, the mouthwash I now use that keeps my gums nice and healthy is a quaternary ammonium salt made from pyridine and another alkyl group, an alkyl chloride, and that keeps my gums nice and healthy. Here I wasn't screaming. If I didn't use that, I'd be in pain right now, what I just did. All right, let me close this down. Let me open up something else. And for one of the last times this semester, thumbs up, people. You see chapter 7? Thank you. Thank you. By the way, seriously, thank you. Zoom tells you sometimes this is what's on the screen that everybody else can see and you can see it, and you don't. At least you people don't. All right. The last chapter I talked about were amino acids, peptides, and proteins. An amino acid has this structure. And I'll draw it another way, which is the same thing. And the nitrogen is always on the amino group on the alpha carbon of a carboxylic acid. Here's my carbonyl. And if R is not hydrogen, then this one carbon right here has 4 different groups. This one, and the R group, and the hydrogen. And it's chiral. And you know what chiral is because we just went through test number 4 on Monday, so I'm not going to do that today. And that makes it chiral. Glycine, when R is hydrogen, is not. And the other thing you should know is you can react amino acids together to form amide linkages, which I won't ask, are called peptide linkages. And if you take a lot of amino acids, you can link them together by forming amide linkages, which we call protein. And protein, when you eat something with a protein, like I ate healthy today for lunch, I had soybeans, navy beans, and some rice and some onions. Oh, it was good. I have it all cooked in my freezer. I just pull it out, shove some in a plate, and nuke it in my microwave. Oh, it was good. I'm trying to be healthier. Now that I've done enough damage to my body over the pandemic, I'm trying to undo that. All those cookies and other good things. Bad, Dr. White. But anyways, when you eat things like that, or if you're not a vegetarian, like I'm not, but I'm trying to be healthy, if you had a steak, hot dog, or hamburger, or whatever else, amide, which is the linkage between amino acids, acid, and water, you get back the carboxylic acid plus the mean salt of the mean you would have gotten if you ate that. If you ate that, you would use to make that amide. And in real life, here's what happens. This amide linkage called a peptide is reacted with acid and water. give this carboxylic acid and this amine salt, and this nitrogen amino group will also react with the HCl. All right, leaving my class, there's 4 main things I'd like you to learn. Well, more than 4. Hopefully you remember there's 4 bonds to carbon. And, time out for a public service announcement from Dr. White. 1, remember for the final, there's 4 bonds to carbon. When I grade finals, about 60% of the problems that are wrong, the student looked at their answer and said, oh, I don't have 4 bonds to carbon. Then they know I got to do something different. The other thing you should remember from final that's helped you most of the semester is you break carbon-carbon single bonds. No, I'll say that again in slow motion. Do you break carbon-carbon single bonds? No, 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 other than when you burn it at combustion. And since I started brainwashing students, their grades went high, sky high, which is a good thing. All right, everybody see my whiteboard? Yay, one more thumbs up, people thing. Thank you. All right, there are 4 things you really should know leaving my class. That'll help you the rest of your life. The first one is, how does soap work? And you should know that soap has a nonpolar tail and a polar head. And water is polar, and things you're trying to clean normally, dirt and grease, are nonpolar. And the most important part of the puzzle is light dissolves light. Whereas ECC, I cover half the board with this light dissolves light. And what that means is if you have a piece of dirt on your hand or whatever, and you use soap and water, the soap molecules, the nonpolar tail of the soap molecules are attracted to the nonpolar dirt or grease. And you should know this forms a micelle, different from the micelle we learned about blowing bubbles. And the micelle now looks polar because the only thing water can see are the polar heads, not the dirt. It's totally surrounded. And the micelle looks polar to water. And the water says to the micelle, hey, you're polar, I'm polar, let's go down to drain together. And they go down to drain together. And you should know this. Next thing you should know is how to describe with words in a general equation 3 things. What happens, how to describe when you eat something that has fat or oil in it, and eat a fat or oil. And what's the functional group in here? An ester. And in your stomach, and I think it's your small or large intestine, you have hydrochloric acid, and water. So you have acid hydrolysis of an ester. And the general reaction is the following. And you could have put HCl instead of H plus. And you take an ester, acid hydrolysis, you get back the carboxylic acid plus the alcohol you would have used to make that ester. I'm going to steal some water, not steal it, just drink it. Next thing you should know is when you eat something that has a carbohydrate in it. And you should know how to describe, how to describe with words and a general reaction what happens when you eat something with a carbohydrate in it. And what functional group holds glucose together in carbohydrates like starch? And that's the acetal. And the acetal, when you react it with acid and water, acid hydrolysis, I thought I spelled it wrong. I'm pretty good this semester. Did I tell you I'm always the first one? First one down in a spelling bee, acid hydrolysis of an acetal. That's what happens in your stomach and intestine. And what's the general reaction? Well, I'll show it for both an acetal or ketal. You learn for test number 2. Acetal, ketal, water. You get back the aldehyde or the ketone you would have used to make that acetal or ketal, plus the alcohol you would have used to make that. Those like the 2, there it is. And remember, in glucose, those are connected together. And the third major food group, now you know, is if you eat anything with protein. And what's the functional group that holds amino acids together in a protein? Amide. Therefore, in your stomach is acid. If I'm not talking, I can spell this word correctly. Acid and water, so it's acid hydrolysis of an amide. And what's the functional group? Amide. And here I'll show the acid because you need the counter anion, HCl and water, and you get back the carboxylic acid you would have used to make that amide, plus the amine salt of the amine you would have used to make that amide. And that's what you do. Let's go through this again. Hold on, I'll wait until everybody who's writing it down furiously can finish writing it down. And good news, this will also be on my video. Oh, I got a question for you. I use the poll, but I'm not going to write. Instead of saying, are you done? Think the question is, have you been watching my videos, or better yet, have the videos helped you? And why don't you answer yes if it has, no if it hasn't, or you haven't used it. Yes, you've used it. No, you haven't. Well, looks like most of you have, so I'm glad it helped. Thank you for letting me know. All right, let's go through this one last time. You should know how soap works. Soap has a polar, non-polar tail, polar head. Water is polar, dirt and grease are non-polar. The important part of the puzzle is like dissolves like. I see I have a question or a comment. Absolutely, by Tom. Okay, and like dissolves like is the important part of the whole equation. And you have dirt, which is nonpolar, and water and soap. The soap molecules, because the like dissolves like, the nonpolar tail is attracted to the dirt, totally surrounds it. I'm just showing you a few, but it totally surrounds it. And therefore, it forms a micelle. And the out part of the micelle has the polar heads. Water sees the micelle and says, oh, micelle, you look polar, I'm polar, let's go down the drain together. And they do. Next, I would like you to know how to describe with words and a general reaction what happens in your stomach when you eat, first of all, fat or oil. What functional group is in a S fat or oil? That is ester. And since there's acid and water in your stomach, it's acid hydrolysis of an ester. And the general reaction is ester, acid, water, carboxylic acid, alcohol. When you eat a carbohydrate, what functional group holds glucose together in a carbohydrate? The acetal functional group. And there you have acid hydrolysis of an acetal. And here's the general reaction, acetal or ketal, acid and water, use the aldehyde or ketone plus the alcohol you would have used to make that acetal or ketal. And finally, if you eat a protein, what happens? What functional group holds amino acids together in a protein? And that's an amide functional group. And when you eat it, consume it, goes into your stomach, there's acid water, acid hydrolysis, the functional group of an amide. And here the general reaction is amide, acid water, carboxylic acid, plus the amine salt of the amine you would have used to make that amide. And with that, the first day of class, I said, I didn't say that, but I said, welcome to organic chemistry. You'll find out my world of organic chemistry is your world of organic chemistry. And now, if I've done my job and you've done your job, which I think all of you have, my world of organic chemistry is now your world of organic chemistry. You know more about organic chemistry than most people on our planet, most people in this country. And that will always be with you if you want it to be. And with that, I'm done. We don't have a lab today. Make sure you hand in your lab. By Saturday, I should have all the points for anything I promised you, and all labs graded. If you see something in D2L where I haven't, shoot me an email ASAP over the weekend, and I'll follow up on that, because you should never be penalized for a mistake I made. And don't forget, Monday and Wednesday, we don't have any class, but Monday at 1, I will send out the email with the password. You have until Tuesday morning. Don't be late, or I reserve the right to having your final turned in. I reserve the right to subtract up to 50 points if you don't do that. Please don't. And with that, I'd like to say thank you very much for being in my course this semester. My only regret is we didn't have lab, so I could get to know more of you better. But I got to meet a lot of you, know a lot of you, which made me happy, because you're all great people. Thank you. Getting gesund, be healthy. And I'm done. Goodbye. Thank you.
Bye, everyone.
Bye. And all of you stay healthy. Don't forget, wear a mask. Somebody made these for me. And I don't know if I showed you this one. And they also made me this one. I can be a chemist, even though I do have KN95 masks I normally wear. They're better than that, but it was very nice. With that, I'll have my office hour tonight. If you have any questions, next week I will. Oh, Anna, what's your cat's name?
Her name's Lulu.
What?
Lulu.
Oh,
Lulu.
I heard that. I said, oh, I have to charge you extra for having a cat in class. No, I'm just kidding. But anyways, I'll have my office hours next week and tonight. Next week, you don't have to show up, but if you want to stop by and say hello, say hello. If you don't, well, you don't have to. And next Monday and Wednesday, I do have to show up for class. So I'll be here for about a half hour, but you don't have to show up. Just make sure you get your test in by final, not test in by Tuesday morning. And with that, any last questions, observations, or don't forget to send gold, platinum, or palladium, or diamonds to the Save Dr. White Foundation. But anyways, with that, seriously, thank you all for being in my class. It's been a pleasure having you here. It's been an exciting challenge doing this by Zoom. Hopefully I've done good by all of you. And with that, goodbye. Game gesund.